Hi again. Okay, so today I wanted to talk about kinematics graphs and interpreting kinematics graphs, and also how to get numerical values from graphs, such as x versus t graphs, v versus t graphs, and a versus t graphs. So first of all, let's start off with the easy one, which is if you want the velocity from a position versus time graph, or if you want the acceleration from the velocity versus time graph, then you just look at the slope between two time intervals. So let me pull up the example that I have prepared on that. Let's do this one. Okay, so what we're going to do is find the average velocity in the time intervals shown there for that graph. It's an x versus t graph, a position versus time graph, and you want the velocity. So you want the velocity between these two time intervals here, 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 and here. All right, so first of all, let's discuss. X versus t graph, the position starts at 0 and then goes up to 10 meters. Now what that means is let's just define to the right as positive and to the left as negative. So what it means is that you go from your origin, your position of choice, to the right by 10 meters in 2 seconds. And since it's a straight line, that means that you're going at a constant velocity. Okay, so you're traveling at a constant velocity. Then you have this inflection point, a turnaround point on an x versus t graph is an inflection point. And that means that you're turning and you're traveling left now. So you're going from 10 meters and then away from that origin, and you're traveling to the left, going back towards the origin for 5 meters. Then you have this straight flat area here. That indicates that you're standing still between 4 and 5 seconds here. Remember that horizontal lines, flat lines, that means no motion on x versus t graphs. Now, you're still going to the left here. When you cross this axis, all that means is that you've gone past your origin on an x versus t graph. And then you continue to go to the left to the position of minus 5 meters here. This is another inflection point. And what that means is that you're turning around, and now you're traveling to the right, and you go back to the origin between 7 seconds. So that's kind of conceptually what's going on. But what they want us to do in this problem is to put numbers with it and to find the actual velocity. Now to do that on an x versus t graph, you find the slope of the line at the particular points in question. So that's easy enough. Let's find this now. We've got, I've got this all worked out here. So let's see if I can set this up so that you can see my solutions. No. And the graphs. No, that's not what I want. Here we go. This is what I want. Stop that. You're so picky. Okay. All right. Now, on this x versus t graph, from 0 to 2 seconds, remember that we're just finding the slope here. And the slope is the rise over the run. In this case, the rise is your change in x, okay? Change in x. And the run is your change in time. And remember what we always do for the slopes and the rise over the run is we take the final minus the initial for both the position and the time, all right? So here your final position is 10 meters and your initial position is 0. So that's what I have, 10 minus 0 meters. And then here, t final minus t initial, 2 seconds minus 0 seconds. That's a 2-second change in time. Then you have 10 divided by 2 for 5 meters per second. Okay, so that's your average velocity between 0 and 2 seconds. And now you're finding the average velocity between 2 and 4. And here, you're going from 10 meters to 5 meters. So your final position is 5 meters. 5 meters minus 10 meters, your initial position. And then your time, final time is 4 seconds minus 2 seconds. So that gives you minus 5 meters over 2 seconds for negative 2.5 meters per second, your average velocity between 2 and 4 seconds. Now between 4 and 7 seconds, it's a little strange. It's not one constant slope here. Remember here you're flat, and then you have a negative velocity, negative slope here, okay? But it doesn't matter. You just take the values of the points. So here, your final point is at 7 seconds. And at that point, you're at minus 5 meters. So that's what you put first, minus 5 meters, and then minus your initial position, which was here at 5 meters at 4 seconds. Okay. So minus 5, and then divided by your change in time, 7 seconds minus 4 seconds. So that gives you minus 10 meters divided by 3 seconds for minus 3.33 meters per second average velocity during that time interval. Now 0 to 8 is easy, okay, because your initial position and your final position are the same. They're both your origin, or 0 meters. And so that means that your average velocity over the whole time interval is 0. Okay? This tells you a lot about the difference between average and instantaneous velocity, by the way. Even though you have velocities for all these other time intervals, except right here, of course, then your net is 0. Your net average velocity is 0 because your net displacement. So hopefully that helps you guys understand a little bit about how to get numerical answers between graphs for this example. So thanks.